All right, so now we know how to take the antiderivative of some trig functions. And I would just like to recall that all our answers had the plus c at the end, and sometimes we can actually get rid of that plus c if we're given some extra information. So let's look at a couple examples with that. So our first example is going to be, suppose we know that the derivative is x cubed, and we know something about the original function, f0 equals 2. We want to actually find the function itself. And this is nice because we won't have to have the plus c anymore. So remember, here we are, we're going to try to integrate this, find the antiderivative of x cubed dx, and here we go. So remember the power rule for integrals, you add 1 to the exponent, so 3 plus 1 is 4, and then 1 over whatever your new exponent is, and then we have plus c. And that's going to actually equal our original function that we have. Now, we haven't used this information yet, the f of 0 equals 2, and let's use that now. So I'm just going to rewrite this so that it's the f of x is out front. We can actually figure out what that c value is. So let's do f of 0. And so whenever you see an x, you're going to put it 0. And then we have plus c. 0 to the 4th is 0, times 1/4 is still 0. So then we just have that equals c. However, we also know that f of 0 equals 2. So then, if you look at the equalities, we get c equals 2. And that implies that our original function was 1/4 x to the 4th plus, instead of c, we're going to put 2. And there we go. There's our original function. Okay, so graphically, what I wanted to show you is how we can figure that out. So graphically. Okay, so we have the derivative is x cubed, and so then if we focus in on that 1/4 x to the 4th plus c, we have, there's 1/4 x to the 4th plus 0 would look something like this. Okay, so that's like x to the 1/4 x to the 4th. And then remember, we had it as 1/4 x to the 4th plus c. So what if the c was 1? So then it would be shifted up 1 and then still have the same shape. So what I drew there in purple is 1/4 x to the 4th plus 1. And then instead of adding 1, we could add 2 and go, and it would still have the same shape. So that's 1/4 x to the 4th plus 2. And then we could even go in the opposite direction, down -1. It has the same shape. And then we could even, nothing so special about 1s, we could go down 1.5, and anything in between there. So we have, this is our infinite number of antiderivatives, and that's why we have the plus c. The slope of the tangent lines are all going to be the same for all points on this graph. So, but if we're given that extra information of f of 0 equals 2, then we can really focus in, and we know that f of 0, so x equals 0, is up at 2. So then we know that we're on this green line right there. Okay, so that's what's going on. And so whenever we have this extra information, we can actually find what c is. Maybe let's make that a remark. extra information about the original function, we can find C. All right, so let's do another example, and let's look at the second derivative here. So we got our second derivative of x is going to equal sine x, and we know that the first derivative at 0 equals 3, and when you substitute in 0 to the original function, you get 2. And we want to find the original function. So in other words, we want to take the antiderivative twice. So here we go. Let's start out with the first derivative, or the second derivative, excuse me, and we'll find the first derivative. So what is the antiderivative of sine? Well, we know that it has something to do with cosine x. If you imagine taking the derivative of cosine x, it gives you negative sine. So to correct for that, we need a minus sign. And then we have plus c. Okay, now we can actually figure out what c is here, because we're given this extra information that when we substitute in 0 into the derivative, we get 3. So let's do that now. So we got f prime of 0 equals negative cosine of 0 plus c. And then on the other hand, we know that f prime of 0 is 3, and cosine of 0 is 1. So then we can add 1 on both sides, and we get 4 equals c. So that implies that we get that the derivative of x equals negative cosine x plus 4. There we go. I'm going to box it because we're at least closer to what we're trying to do. Now, the problem is asking for the original function, so we still have to take the antiderivative once again. So here I am. I'm going to copy it up here so we can still see everything. We got negative cosine x plus 4. And let's try to take the antiderivative one more time. So we got cosines involved, so we know sines involved here. And if we take the derivative of sine, we get cosine, so we got to keep that negative sign. And then the antiderivative of 4. Now imagine we got x to the 0 here, and we got our 4s are along for the ride because it's a coefficient. So we add 1 to our exponent, so we got x to the first, and then we divide by the new exponent. And then we have plus, we could do c again, or we could do d. We could use c because we already eliminated it, so it doesn't matter if you choose that. Alright, so let's clean it up a little bit. So we got f of x equals negative sine x plus 4x plus d. We know f of 0. F of 0. So whenever I see an x, I'm going to put a 0. Okay, we also know, on the other hand, that f of 0 equals 2. Sine of 0 is 0 plus 0 plus d. So we get 2 equals d. So, in general, we can write f of x equals negative sine x plus 4x plus 2. And there's our original function. And we successfully completed this example. All right, so with that, we're going to move on to the next video.